Right. I'm just back again. I'm gonna do some streaming, Rust coding, and Direct3D12. Um, so I'll just get up to where I was at last time. I've done a little bit of stuff in meantime, but not that much over the weekend. I ended up, well, starting the process of looking for houses, and it's been quite a lot of stuff to think about. So that's eaten into my coding time. Um, just ran that demo then, and it wasn't working properly. So not an ideal start. Geometry primitives. No, it was this. I was just doing some bits and pieces trying to sort out improvements for how to handle push constants and working out offsets and kind of setting them up. Let's see if this just fixes it. Reload complete. Oh my god. It was this. Well, not ideal. Starting at a deficit. Right, here we go. Interesting. Right, so I've got it working again. Let me go into the to-do list. Not very good, to be honest. I tried to do a few fixes. Oh, this is because it's in the other. Got too many things going on. Should probably be a bit more prepared. Right. To do this. Right, so this was, I was looking at this get num 32-bit constants function. I added a little helper function which would return the number of 32-bit constants, but it doesn't work properly. So that was returning 0. I did look at fixing this GPU time inconsistency. So down here, there's just a little GPU timer that's obtained by a timestamp query. If we change the sample, oh, that is working at the moment. Oh no, it's not. Now it's going massive. So what's happening there is there's some tracking for the views when they get rendered, and as we change between view sets, or basically the stats ones aren't being cleared, and the code is iterating over all of the views and taking the min and the max GPU timestamp. So previous ones that haven't been used or aren't being used at the moment have an old stale timestamp in there. So I might just wrap that up. I did try and fix it, and that caused a crash, or, well, not a crash, a panic, unwrapping a value that had been removed from a map. And I did try and fix something else, which was when editing pipelines, configs in PMFX, which is in here. Let's see if we can do an example. Say, for example, I could comment out one of these states, and some of them will cause a crash. Let's see, may as well just do a test. So run target blend states. Let's go with additive. I think this one's working actually. So I have been doing some work in the PMFX like config and shader system. Okay, cool. So if I try and edit that, it's saying it's missing blend state or render target blend state additive. That's perfect, and that's the kind of error handling and feedback that I would like. Reinstating it fixes it. But I can, for example, try and remove a pipeline completely. Let's go to, what have we got in here? Let's go to raster states one. So we've got cull back, cull front maybe. So if I take out cull front, the entire pipeline, that's compiled successfully and it's still working. So one bug is that once they're loaded at runtime, they're not unloaded if they no longer exist in the config. But the compilation here should kind of complain about that, I think, as well. So that's something to kind of think about. So I'm not going to work on that now, but that was just something I was looking at. And then there's probably stuff like raster state. Let's see, callback, which is in here. Raster state's call back. So if I comment this one out, I think what's going to happen. Okay, so now this is error while processing, and then it's just a kind of unhandled exception, key error callback. So it's kind of all right, but I would like to just improve that error message and that error handling, so it says missing at raster state callback, and just make that user experience just the little bit better. So I started looking at that partly, but then there is also a case of if you completely remove something from the configs, it might be referenced in code somehow, and it's possible to delete it, and then the game, the kind of the runtime while it's running will still have that loaded, but the next time you load it, it will be missing, and that disparity might introduce, just a little bit of confusion or problems. So that was something I was looking at, and I've sort of done a bit, but largely been unsuccessful. GPU timestamp inconsistency, I tried to fix, again, largely unsuccessful. This getNum 32-bit constants function, also been unsuccessful. So that's that one as well. Fixed GPU time inconsistency. It's not broken, it's not fixed. So those days where you try, I mean, I only did a bit of this on my lunch break. I'm still working as well. But you try and fix some stuff and you get nowhere. Sometimes that is just coding for you. So, I just have to kind of power through. Let's see, maybe I'll just quickly do. I hadn't been posting about this for a while, but might just post that on my Twitter, see if anyone fancies joining. Okay, so cbuffer instanced. Right. Okay, so these are some small tasks that I was looking at. UVs need flipping on geometry, finding offsets. I'm not going to look at those now. They're just like little tasks. What I'm going to continue with is working on a material system where I was talking about it last time. So what I thought is using structured buffers, C buffers for the cameras instead of push constants, so it allows to have more kind of camera parameters or constant parameters for the kind of view. And then there's some stuff about creating a texture with a bespoke heap instead of using the default one, so it can be controlled from a higher level, and we can kind of recreate things in the heap, or just sort of have a bit more context about what we're doing. So last time I was looking at that, and I left some comments in this file. I think it was a draw RS. Okay. And I had some little comments. So the idea was to have a material ID and an entity instance ID where they're in the vertex buffer, and we can draw like a bunch of stuff with instancing and material ID, which could at first be drawn per material per vertex, per vertex buffer, and having potentially an instance buffer as well. And then draw C buffer per entity, which contained world matrix. I did start to think about whether to use structure buffer or C buffer, and basically I had a look into it. There was a good answer on gamedev.net where it was MJP and another guy, long time game dev posters. I used to go on there probably about 17 years ago now when I first started coding, and someone else asked a question, and so the general response was that for things like camera view constants, you would use a C buffer, for the camera matrix, for the for the kind of camera position, I don't know, any kind of view constants, because everything that gets drawn in that pass will index into that, or use it. And then things like per that might be different per draw call, or instance or fragment, where you might be jumping around with the accesses, you want to use a structured buffer. So this came to material ID, entity ID in a vertex buffer, and then a structured buffer per entity, which would contain a world matrix, which we can look up by the instance ID potentially, and then we could have a structured buffer per material, which like has the actual material info, and then we can look up textures, and then we could have a C buffer for like view constants. And that means it's not using push constants at all. I think the combinations of which bits of these I'm going to use is slowly kind of taking shape, but I'm just going to make sure like anything is possible, really. So essentially I need a kind of another one of these little samples, which is going to be, I'm going to maybe just call it draw material, and this is going to be the material system. I considered doing draw structured buffer instanced, which might also be worth doing just to make sure structure buffer works. And as I touched on it in the last stream, I was looking at like the bindings of things, how to bind a heap on the different slots in the descriptor layout, and how they kind of correlate to the different types of bindings between constant buffers and shader resources. So maybe I'll just go for the draw material. Um, oh, another thing I have done in the meantime as well, I updated to Bevy ECS 0.10.0. It wasn't that much work, but at first it seemed like it was going to be a massive task because of how the schedule had changed. But it's nice to kind of be up to date, and actually it improves the flow of this. So actually, maybe I'll do a quick demo of that. Uh, so now in here you can, when you register the functions in the dynamic libraries, you can kind of add the after or in base set in here, and there's the categories. So it just makes the ordering of it a bit simpler. And previously I had this batch phase and like kind of some different things, and it was a little bit messy. So it's actually a bit nicer now. I'm not using it too much. Pretty much there's a few stages: update, batch, and render, and they get executed in order. So update does the update, batch sort of bakes matrices and things like that, and then render uses those matrices to do draw calls. So they just go in order. So basically, there's going to be a new draw sample, I think. It's going to be drawing material. Push constants, texture, cbuffer instanced. I don't really know what kind of primitives to use or anything. It's going to be essentially very similar to these things, these existing ones, I think. Because I just wanted to be able to draw tons of stuff with different materials instead of the same material. Set up draw material. That's going to be what it's called. So here, this one created a constant buffer previously. Oh God. I'm in the wrong sample here. In the wrong VS Code instance. Okay. I'm gonna close that one for now. So this is the one that has the plugins, and it also has the Rust analyzer working inside it. Primitive draw. So this is a draw sample, and set up draw material. And now the problem was I was looking at this, and I wanted to know, I wanted to do this, right? So actually, this is a little bit annoying in that used as a constant buffer for shader data, we have none in vertex or index. So I don't even have structured buffer implemented in the Direct3D backend implementation. Buffer usage, create a constant buffer view. Let's have a look at what D3D is saying. Unordered access could be a thing. Depth stencil view. So I don't think you create a structured, I think it's a shader resource view, right? So I think for a buffer, we can create a shader resource view because I'm trying to do this as much kind of without just going through the docs or without going through, example code. And so I have done this stuff in other engines and at work and that sort of thing. So I believe we can make an unordered access view on a buffer, and we can also make a shader resource view on a buffer, which slightly UAV index is none. See, now this, because this is a buffer usage, that really probably should be flags. Descriptor type. How does textures do it? Texture usage. So yeah, a texture usage can be a shader resource and unordered access, which is kind of how I want my buffer to work. So this is actually a bit of a bigger change, which is going to require code changes to the samples and all of the underlying code. I think I jumped the gun by not thinking about structured buffer in the first place and just doing an enum. So buffer usage. I hope this isn't too bad. So buffer usage, we're going to go with texture usage. Bit flags. Bit flags as well. The same as, it's almost the same as texture usage. Ugh. Keep that running for now. Right. Buffer usage, well, they're going to be basically similar, these. And the comments are uses a vertex buffer binding. We don't have depth spindle render target or vertex buffer. I do that as 1 by 0, which means, oh, we've got an index buffer binding. Formatting. I'll go with vertex, non-vertex index. It's possible some of these will be incompatible with one another. For instance, if you're a constant buffer or vertex buffer, you might not be able to be you might be able to alias the data though, I suppose. So I wouldn't write it off, but I'm just thinking aloud here. So we have a constant buffer as well, and they're all the original types. vertex buffer binding, index buffer binding. Use its constant buffer for shader data. Constant buffer. 2, 3, and 4. Right, buffer usage. So buffer usage is still did we change them to caps, vertex, index? So, just see where else we use buffer usage throughout the solution. GFX RS, D3D12 RS, draw RS. I do actually need to open this in the other. So I've mentioned about this a few times, but I have one repository which has the main hotline lib and then it has the plugins inside it. The Rust analyzer does not like the plugins directory being nested inside it. So I have to sort of do this horrible, confusing process of jumping between the two workspaces, which as an end user point of view, once the engine is more robust, you would just be working in the plugins, so it doesn't really matter. But for the time being, it is a little bit annoying. So GFX front end traits. Oh no, I want to look for buffer usage. So annoyingly, this just means any place I've used this. I'll update the readme last. Bindless. Let's go on to the first sample is triangle. I mean, this isn't even going to compile, is it? Let's do a plain old cargo build. Right, I'm gonna have to close that now. That wasn't very. What's this? What's my errors? Link.exe. It's closed now, mate. Close that. It's not running. What have I got? GitHub. Close some of these things. What's this? Oh. It's not even the right one. Man, this is so confusing. Hotline workspace. Okay. Oh, I mean, it shouldn't have been linking because it's not going to compile. Buffer usage. Oh, it's not that bad, actually. Oh. Text usage, buffer usage. Do I need a separate bit flags for each thing? Bit flags. No, there's a few in there. Bit flags. Right. Well, while I'm here, I'll move those all into one. Bit flags, bit flags. Conflicting implementations. I think it's just because buffer usage is here as well. Okay, that's it. Oh no, not buffer info. Maybe we don't need a copy and a clone. Or a partial EQ. Let's see if that's... Right, okay. Well, that's okay. So now my buffer index is all changed. My usage flags is all changed. Cargo build. Okay. Create buffer with heap. So firstly, that is, we renamed it because it's a constant, and this flag things it needs to do contains. Can't say I'm a biggest fan of the old bit flags in Rust when you kind of, you know, come from a C background where just sort of oring and things is quite a natural thing, and now bit flags you've got to do this contains and quite fiddly. I'll copy one of them because I'll probably need it again. Here we go. Match. So essentially it's not going to be a match anymore because we can have multiple. So if usage contains, that becomes this statement. And then we have, well, that was vertex. We've got vertex, we've got index, and we've got constant buffer. Oh, no. Stick on in here. But then we also have constant buffers. Constant buffer and constant buffer. That allocates a heap in the shader resource heap. So it has a shader resource view index, even though it's actually a CBV index. Ooh, that's going to conflict a little bit with the shader resource. Constant buffer view desk. I'm going to rename this. So just for a quick overview, a buffer, I'm trying to do like the metal style buffers and texture handling where we have a core resource, and then internally it can create vertex buffer, index buffer, shader resource views, and that kind of thing. And then it's down to you to kind of set the flags, and you can kind of use a buffer how you want. Okay, buffer. Right. That can become CBV index. Right, because that's what it is. It's not a shader resource view. The buffers are allocated into the same heap as texture shader resource views, but let's see where else it's used now. Now I've got a bit of better handle on it. Create a read back buffer. So this get SRV index is actually incorrect. That was that. So Rust analyzes dead. Right. GFX. Get SRV index. So that needs to change. Get SRV index. Hold on. I'm gonna just right. That was what it was previously incorrectly called, SRV index. I'm gonna call it, rename the symbol, get CBV index, which should hopefully sort out all the places it's used in. Let's see what cargo build is saying. Right, usage. So these are all alright because I'm only using a single one, so it might not be too much work to sort out index. Come on. Oh. Index, vertex. Okay, this might do it. Hi. I'm just gonna comment these out. just so it fixes that warning. Right, that wasn't as bad as I thought it was going to be in terms of fixing that up. But I need to fix up the samples and then all of the plugins as well. Just going to be back 1 second while I feed the cat. Lights on. Come on. Come on. Ooh, right, okay. Ah, that's nice. Now, right, back to where I was. Well, firstly, we should check this still works. Triangle sample doesn't compile, or a bunch of them. I don't care about those. Triangle. Vertex. Bindless. Vertex and index. This one, index. Constant buffer. What is going on here? Right. Triangle debug. Right, okay, so that works. Always Windows leaves that little timer thing when you launch an app. I don't think it's doing anything, I just don't know why it doesn't change it. So that one works fine. May as well check the other samples while I'm here in kind of rough complexity order. ImGUI demo. Here we have ImGUI. Bindless. This one had an error warning. That was just because I was doing some work the other day, getting 3D textures working. I just stuck it in there, so that's that. Bindless is working. And then play video. Okay, that one works as well. Cool, right, that's all working. There wasn't that much to change, so that's all right. That's always welcome. Okay then, now back to, I'm going to still have to add code into the back end, so I'll stay in the hotline workspace. Okay. There's a bunch of issues. What's this? This is the draw index vertex buffer instance. So we're a vertex buffer, of course. This one is the raw material, which we just did. Buffer usage is going to be shader resource And there's shader resource and unordered access. I might call it structured buffer actually instead of shader resource. It That's kind of what the textures are. Like a sampleable texture is a shader resource, but maybe that's a little bit ambiguous. But I don't want to dwell on. I suppose I'd best get it right. Constant buffer. And then we've got a few more constant buffers. Oh, shader resource. Right, well, what's this saying now? Right, so that's just working cbuffer instanced. So back to square one basically. But now with buffer usage shader resource view, here we go. Same old story. Can't go to definition, which is very annoying. GFX. So I did want to add the get CBV index function back in. Oh no, get SRV index, sorry. And these are the wrong way around. These comments. So this SRV CBV index is the index into the bindless like table that you're accessing the resource from. And that's obtained by the offset within the heap, basically. They are technically the same, but the view is different, so we should take care with that actually. Get SRV index. Go to definition. Right. So we can have an SRV index. That's it. We don't need the other thing. There's going to be a few places in here where we need to initialize this. So here, if our buffer usage is shader resource, we allocate into the heap, create shader resource view, and then D3D12 shader resource view desk. Okay. Format dimension. Shader for component mapping. Look at that one. Constant buffer view desk. Format view dimension. Yeah, I know. Right. Format is I've got another one of these here. DXJ format, view dimension, sub view dimension. So yeah, we can have the dimension is a buffer, which is perfect. So that's exactly what we want. Dimension. And format feel like it's just buffer. It's unknown. You know? It might be typed, but DXGI format unknown. Right? Create shaders, resource view. SRV index. Oh my god. I don't know if it's VX Code, Windows, or my mouse, but something keeps selecting stuff in a very annoying way. SRV index. SRV index. What's up with this now? Option. View dimension. View dimension. Anonymous and shader for component mapping. See that? I did a double click and it selects the entire file. So that's like doing loads of clicks, right? Quadruple click was triggered by a single click. And then sometimes a double click's triggered. I need to debug it because it's really quite annoying. Come on, default shaded. It might have a default. Let's see if it's got default. Default. Come on. So I don't think we need those. Create shader resource view. So in other places I'm using it. You have to pass the resource in as well. So it's shader resource view. Resource, a desk, which is an optional desk, and desk descriptor CPU handle. That's the handle. Resource is the buffer itself, which is this buff. And what is that? A P resource. P0, where P0 is this. I think I can pass. Is it a reference to a buff? Oh, oops. Right, there we go. Okay, cool. That's working now. SRV index can be passed in. Right. Okay, now just fixing up the other missing places where a readback buffer is only a buffer, so that just has none of these kind of aliasing views. Is that it? I can't believe that's it. Oh, cleared. Okay. SRV index is never read. That's fine. I need to implement that in the function for get SRV index, returning the wrong thing. SRV index, right. So now, almost there. Structured buffers might be possible. Okay. I'm going to just relaunch that. So then back to the plugin sample. I'm trying to think if I might need to set up anything else in the background. Or let's keep calling it the plugin sample, the plugin workspace. Plugins workspace. Oh, got a sore neck. Got a sore neck. Too much sitting at computers. Right, GFX. We don't want to be in here. ECS demos, lib, ECS demos, draw. Right, set up draw material. So, don't know if I've got any better shapes or more interesting shapes. Just one sec. What have I got? Geometry primitives. Ah, okay. So like in the, what do we use here? Capsule, torus, helix, pyramids, cones, and prisms. And then in the vertex buffer instinct sample, what's it doing? All the platonic solids, I think. Got tetrahedron in there. Yeah. So I'm going to use a different batch of geometry. These ones got capsule. These ones are using the best ones. Pyramids and everything. But didn't use spheres. So I'm going to use the spheres and what else have I got? Cylinders. Haven't used those in the other sample. Cylinder, spheres, and chamfer box. Chamfer box. Maybe spheres and half spheres. They're more nicely UV'd, so they're going to lend themselves to texture coordinates. Create sphere mesh. And you need a bit of detail. This is going to be a bit more of a stress test. 64 subdivisions. What does a create chamfer cube mesh take? 64. Maybe. Radius and segments. Don't know what that one was on. It's like 0.3. Maybe I'll just check. Primitives. Chamfer cube mesh is 0.4 and 8 subdivisions. So I'm just gonna copy that one. What was the one called? Sphere mesh truncated. We'll add those in as well. Sphere mesh truncated, and I think that'll do for the time being. So not many, but I think the cbuffer test is actually hogging all of the primitives. Okay. So self-draw material, we have a few meshes that we're looping over, and we create a shader resource for each instance batch. I'm going to change how this works. Instance batch. Each instance batch had its own instance buffer. Now, the instance buffer is a shader resource type. The problem is actually here, my vertex format. Oh no, it's okay, because my vertex format, I need an instance buffer that's a vertex type instance buffer was my original plan. Right. So it's kind of same as this. Instance buffer is a vertex buffer of mat 3, 4. I might just get this working with a vertex buffer. And then the vertex buffer is going to change to only take the instance ID or material ID actually. We already know the instance ID of the mesh or the draw call. But it might be worth allocating that properly so we know where it is in the heap. So the pipeline is going to be called mesh. What was that other one called? Mesh debug C buffer instanced. Mesh debug vertex buffer instanced. Quite a mouthful. So we loop over all the meshes. We create a parent. I don't think it does that for the. Yeah, it must do. So each mesh is an instance draw call set. I'm going to stick with that for now. The idea in future is you make one draw call which can draw all of your meshes by either executing direct and changing the vertex buffer, or by, well, you can do mesh shaders, or by kind of copying the mesh data into a single bound vertex buffer and then changing the offsets. So I'm sort of slowly going towards that direction of basically drawing everything, all meshes with one draw call on the CPU, and they can have all different materials and they can have all different matrices. But I'm just going there baby steps at a time. That's not applicable anymore because that was referring to C buffer limitation, which is 65535 bytes in a C buffer. So now this one seems like it's going to be all right. I'll just compile it. I might need to just restart here so I can go get this. What's this done here? Right, just gonna run that again from here, just so I have the output of the compilation in this terminal window. So we're not using this heap. The heap is none, and that is because the reason I used a designated heap for the C buffers is so that the instance ID would match the index in the constant buffer array. That's going to change. I'm going to do that by working out the index, or making a structured buffer which will have the matrices in potentially. But I'm just going to get this drawing on screen and propagating through first. So in the libs kind of setup, render meshes, vertex buffer instanced, we're going to use that same thing. Render test, draw tests, draw, what did I call it? Set up draw material. This one's not going to have all the permutations of C buffer vertex instance, blah blah blah. This is kind of what I think. Oh my god, why has that happened? The material system should work like. Draw material, it's appeared in there, but I don't have set up draw material. Essentially the same as the vertex, draw vertex buffer. So this one's called draw material, and then the kind of the description for it is create what would the old one say? Create instance batch. Create instance batches for each mesh. Draws makes an instance draw call per mesh. Instance data. Instance data is stored in a structured buffer. So it's going to be the world matrix. We're going to look up in a structured buffer. And then instance like ID and lookups stored in vertex buffers. Instance data is stored in a structured buffer. Material data stored in a structured buffer. Technically, you don't need the material lookup. So only the material IDs are necessary, I think, to store in the vertex buffer. And then we can use the instance ID. Oh no, actually, the instance ID does need to change, because if we draw them in a batch, I'm going to have one big buffer which will have all the instance information in it. I'm also, and this is probably a good thing to put a note on, I also want to try out using persistent mapped buffers for this. So persistent mapped buffer. That's something to consider as well. So that's where you basically you can bind the buffer once and just leave it bound for the duration of the program, with some potentially swapping between each frame, so you don't ever get a tad read or a tad write. Right, so draw. We've got this. Create instance batches for each mesh and make instance draw call per mesh. For the time being, that's going to change. Their material IDs are going to be stored in vertex buffer, and then also instance ID. I mean, instance ID, entity ID could be stored in there, and then world matrix instant material ID could look in the structured buffer. So here you've got kind of like a bit of double indirection. You'd be looking up the entity ID, look in the instance ID, that'd give you your world matrix, and then you would jump around into the material ID. But you could look up the material ID in the vertex shader and then pass it through as well, potentially. There's quite a few different ways this could go, so just keep slowly chipping away towards this. So batch world matrix instances, a mesh debug vertex buffer instance. Now this is all using that same stuff. So let's see how it goes. It's taking a while, and I mean this is just bothering me. Cargo check. Cargo check. I don't want you to check it. Test. Draw material. Missing function, setup draw material. Right, okay, this old chestnut. Gotta register that function in the setup. System, oops. System func. Six seconds. Right, okay, cool. Okay, anyway, that's fine. That's quite cool. We got the spinning ball theory going on here. And these guys, okay. Right, so then the idea would be to be able to have tons of these. And I don't really know currently the benefit of why I'm going to put the world matrix into the structured buffer instead of into a vertex buffer. But I suppose this is part of this process, it's trying to figure out what should be the approach. So now I have this, I could actually do, you know, a larger number of instances. Let's go with 64 squared. This has crashed or something, hasn't it? This is annoying me. It's gonna run. Like, it was pretty rock solid the other day, and I've been making some changes, and I don't know. It's got no output, no error info. It's hot reloading as well, so it's not really possible to debug that. Right, so this feels fast. This GPU MS thing will be more useful once I've kind of got this working, because then I can see. The idea would be to have a way to kind of increase or decrease the number of entities and profile roughly, you know, what's the performance like. Maybe dig into it a bit more inside, you know, a profiler, and see what's going to be the best way to deal with large numbers of instances. Because the other way is like having an array of, you could have a bindless array of structured buffers with a buffer per instance, or you could have a massive array with all of that in. And I don't know what would be the benefit of either over the other. Yeah, maybe I'll do that this time actually, and then that makes a bit more sense that you would have a separate buffer, small, containing world matrix and material ID per entity, which can be looked up, and then you have a structure buffer per material, and then that one can also be looked up. And then it might be a juggling act between deciding which ones you have as an array, or which ones you have I mean, they are arrays. The confusing thing is the bindless part of it makes it a little bit confusing, that you could have an array of structured buffers inside your bindless heap, or you could index into the bindless heap for each individual structured buffer. And I think that's what I'm going to do first. So this is kind of moving towards that system. I suppose it is kind of equivalent, really, which is, let's see if we go for like 128 squared, where it says this is going to crash probably. I need to know any more info. Oh no, it didn't crash. It's running slow. What's 128 squared? I don't know. This has crashed. Or it's taking a long time. Well, I've not seen this before. Damn. Right, error running reload. Error running client. You're not giving me... Need some better ways of debugging that. Annoying. Supposed to be seamless hot reloading and it's not. It's bringing me back here. Leave me alone. Right. Right, 64k. I suppose that's a good thing to know. At the moment, like going up an order of magnitude or a power of 2 is, it's chugging. Right. So now, instead of it being vertex buffer, well, I'm going to still make a vertex buffer which contains these batch world matrix indices. There it is. So I want another function like this. This does buffer update. Updates does. We map and we write to it. We map and unmap. That's where persistent buffer. It wouldn't need to do that. Just one sec. I'll be back. Yeah. Right. Okay. So I think I can still use that normal update. Doesn't really matter. Instance batch buffer. We obviously can't bind it, so we need we need two things. Batch world matrix indices. I'm gonna just copy that. Batch world batch material instances. So they can still be an instance buffer, but instead of writing a world matrix into it, I'm just going to write an ID. And then there can also be another kind of entity, what I was dealing with elsewhere, where we create a buffer, which is the, oh no, another component would be the individual yes, so I need, what's instance buffer? Instance buffer has a heap optional, a buffer, and an instance count. That's fine. My case now to switch. Oh. This is mind bending. Not really that hard actually, but there's just so many like combinations of things to think about. Okay. So an instance buffer, I don't think I'll give it a heap. We can allocate into the same normal heap. So what was this one be called? An instance buffer. An entity buffer. And that's actually just totally unnecessary. Just a new type, a buffer component. Because these could be used for all sorts of things. Much like how I have the texture component. I believe, does that go in the test rs? Nope. Lib rs. Ugh, why does it do that? Lib ECS source. Not that one. Lib ECS demos. I had some share. Oh no, it might be in that one. Got to switch the stupid workspace again. ECS base. Right, okay, yeah. So I added these texture component, time component. They're just small, granular structure array sort of things, but a buffer one will be very useful. I nearly said useless then. So I'll leave it just where it is for now while I'm developing. So buffer component, that's just to give an entity something to grab onto. And we can generate a buffer on instance. That's a batch. A bundle. Instant. We need similar kind of instance material. I think we still need a parent, pos rot scale, world matrix. buffer. This is going to contain our information about our world matrix and our material ID. And we also want a material ID, which is going to be, well, how many materials do you think you'll have? 65535 seems a lot, U16, but I haven't really got full, I haven't really tested a full U16 or U8 pipeline, so realistically it's going to be a U32. But there, again, I need to just go back to here. So we have a texture instance, which is a U32. This is the thing with Bevy, sort of ending up with like lots of like these aliasing types, which I understand why it does it, but sort of, you know, I wish I could just have a U32. I suppose I need another name for it, but texture instance and material instance, they're kind of similar. But that's another alias. I just imagine I'm going to have millions of those in over time. I suppose I'll try and like lock this down. Oh, I put it in there now. That means I'm going to have to rebuild the whole thing. Right, okay, material. Which is the material instance. It's not, it's a material ID. That's in here. I can call it that. I can't be bothered changing it. It's the same. It should be text. It could be ID instance. I suppose it doesn't matter. Instance material. That's a struct. A material instance is another thing. So that's also confusing. Gonna have to sort of cut through this, otherwise I'll just be faffing around trying to decide what to call things for a while. So we've got a buffer component and a material instance. Oh my god. I wonder, can do multiple batches? We call this a material go. That's it. No, that's the same thing. I'm wondering if I can just do a, instead of doing a bundle, a tuple of bundle, maybe. Thomas Tuple, if you like Thomas Tuchel, or don't like him. Just always think of that. So can I do, I've got an instance spawn. You have to spawn a single bundle. Material, we've got another material instance going on. Oh my god. Go away. Yeah, that one. Oh no. Oh, these were actually, that's fine. I might not be using this. This is extremely confusing now. Right, that can do something like this anyway. I can just check. That has no, should have no things. We've got albedo map, we've got material. These were little ones that I made before. I forgot about them. When I was fiddling around to try and start thinking about this. So material instance, and we can create it as like this. No, I don't think this is going to work. And that's also extremely confusing because I've called the same thing twice. That one's not matched. Oh, it does work. Bundle and then another bundle, right? So we have an instance, and as I said before, it's got the similar thing. Instance material, instance material. Inside it, we had a buffer, which is buffer component. And we had an ID, which is material instance, which is very confusing. So I think they should be changed to texture ID and material ID. I just think that's going to work a bit better. And then we've got an instance, and then we've got an instance material, which that makes sense to me. The instance is the entity. That's an instance. And then we got an instance material. Okay. And then we're missing buffer and ID. So the buffer, we're going to create a buffer with basically the same as this. Or similar. But this is going to be a shader resource, which also could be called a I've stuffed that up, haven't I? Buffer. Device, create buffer. Instance material, missing flags, create buffer. Buffer component. So that needs to be a new type. Like this. Right, okay, cool. So it's not a vertex constant buffer. It's a shader resource. And then we're missing instance material. The thing here is we need to create the buffer and I need to create the buffer. I need to get the shader resource view index. Now this is very daunting. It's not a buffer. Come on, that is so annoying. Selecting everything. Device, create buffer, buffer info, initial state. We need this garbage. Need another? No. Just need one less. That's that. Does that close off create buffer? That closes off nothing. Okay. Right. Now this stuff. Oh my god. This mouse. I'm going to have to get a new mouse. Buffer is buff. Fuck off. Selecting it like that. So annoying. So this is a buffer component. Right. And then ID. And this is a bundle. I think I can improve this in how it's sort of going through Bevy. ID. Let SRV index. That's going to be what I was implementing before. So it's buff get SRV index. So that's the index of the shader resource view, and it's an option of view size. We can expect that, and then it needs to be as view32. What do you want now? This is tedious. I should have done this differently, but it's all right now. A material instance. Oh yeah, it's because buffer is quite reusable. I don't want to make instance material with a buffer inside it. It can be a separate component array. So that was the reason why I'm doing a bundle instead of a struct. That was like the tiniest bit of water. Okay. So now we create a vertex buffer instance based, which is actually got a matrix 3-4 in it. And then this buffer also is a matrix 3-4, but I want to change that. And this is also now where this is kind of hub struct material entity instance data. Right, so the instance data is a world matrix, which is already been baked for us. That will be done on the CPU, but in time, I might look at ways of shifting that on the GPU. Then there was going to be an ID for material instance, but we need probably going to be 4 floats here, 4 U32s instead. So IDs, and that is going to be yeah, that might be nice. Yeah, IDs, and they are going to be a vec for you. Right, okay, so that's my entity instance data. And that's what goes into this. So the stride of the buffer and at this point I'm doing 1 element per buffer, which so there's a buffer per entity, which might be excessive, and it might be better to do an array and have 1 single buffer, but I'm just going to do it this way for now. So a structured buffer per entity, and then this vertex buffer data just becomes something a bit more simple, which is going to also be a vec for you, which is going to contain the entity's ID in there for looking up the is it this? That's actually that's not correct. I don't have any materials at the moment, but what I do need, instance material instance, that's the instance of the entity. And that thing, one of these, an ID needs to be used for looking up the entity's world matrix, and one for the material. So there needs to be another component. But like now I've got to define another component just to how do you do it again? To write one of these. Right, entity ID. Is that even a thing? U32, right. So U32 of entity ID is going to go into the entity's components. Can I stick another one of these in, or does it need to be a bundle? I don't know. Entity ID. That's SRV index. And at the moment, this material is actually, I haven't created one yet. Oh, expected one argument and found two. This is getting a little bit confusing now. Is that okay? Right. That's all right. All of this tuples stuff becomes a little bit hard to follow. And I can't stick an entity ID in there. Maybe that's wrong. Damn. Right. Instance material is fine. I'm going to make this in the bundle as well. So instance material, there's entity ID and material ID. Entity ID, and that's going to be material ID. Okay, buffer, entity ID, material ID. Cool. Now this one's saying we're missing material ID. It's slowly becoming a little bit clearer to me. I realise it's probably all absolute nonsense on screen on a stream, but I'm doing it now. So SRV index as U32 as EU32. Okay, no. Oh, it's entity ID. Right, that's cool. It's not complaining. Rust Analyzer, come on. This is actually going to die now because I'm trying to render a pipeline that's not going to work. And I'm not going to be binding the correct buffers. but yep, GPU hang, lovely. Right, oh, my neck is killing me. So now I need to start adding some new shaders and pipelines in order to do this. So let's see, we've got setup draw material, batch wheel matrix instances, which that's not really at all what we want to do. So I'm just going to take that away. And I guess I just want to make sure I can, doesn't need that. Let's see, I need to go into the shaders. Debug. Okay. Right, I'm going to call it mesh material. Call that. All the renaming of this last time, I was renaming the function names and the pipeline names because, like I was just dealing with, when you got so much of this stuff, you can get a lot of overlap of terminology and ambiguity in that terminology, and it's kind of full-on job to just enforce consistency. Right, I'm going to call it mesh material instanced. Mesh material instance. So what it means is we have a VS which looks up a buffer based on an ID for world matrices to draw. And then we're not going to have draw push constants. We're going to just get those. We are going to have view push constants, and I'm going to move the view push constants. Possibly, it might be all right to keep them in push constants, depending on how many you need. But it might be kind of better to have them in a C buffer, and then because you don't have to then push them every draw or every view, you just have to push a smaller amount of data. Again, really just I'm kind of thinking things through quite a lot, or maybe overthinking things here, but the aim is to, what's mesh debug got? Depth stencil state, depth test less, callback, triangle list. Okay. So yeah, we've got VS mesh material instanced. And then we've got PS mesh material instance. Okay. That's those, and they don't exist yet, but we go for HLSL. VS mesh push constants. So this becomes VS mesh material instance. Okay. And we get all the world matrix. We don't have a world matrix. WM. So I'm just going to ignore that for now. Because we should have view projection matrix. I'm ignoring the actual instancing part of this. And then the PS texture. Let's be a normal basic texture. Here we go. Mesh. PS mesh push constant texture. PS mesh. What was it called? Material instanced. I'm not going to do anything in there at the moment except outputting a color. Fuck off, this mouse is driving me mad. It's going to be green, right? Green for good. Green for good. Not good. Crashing. So that could be in the setup of creating the structure buffer. The flags might be invalid. Let's see what the D3D debug layer is saying. Shaded component 4 mapping is set to an invalid value. Hmm. So in the structured buffer, do they all have to be the same type of data? Okay, well, I'll fix those in the D3D implementation. It's getting on a bit now. The other ones I've been doing of these streams have been about like an hour 45. It's sort of where I start to fatigue. I can code for a lot longer, but talking at the same time is quite tiring. Doing it is actually quite good practice for like if you do code interviews, code tests. I do quite a lot of pair programming at work or assisting people, and that sort of it helps, but it is an extra cognitive load that's quite demanding sometimes. What are we looking at? Create buffer. Create buffer with heap. Create buffer with heap. I think this is the one. Show the resource, right? Okay. I'm sure this is somewhere else. Okay, that thing. Well, like invalid value. Come on, like why would you not make the default shader 4 component mapping the default in the default? The default's going to be 0, isn't it? Create buffer with heap. So I thought, I could utilize the default there, but Windows is Windows. Windows is Windows always. What are they called? Shader or component mapping. It's going to be that. Oh, I had the whole thing. Right, that's that. And then unknown when creating a view of a buffer. Now, I haven't had to consult the internet so far or do anything. So, can we only use floats and ints? Can we not mix floats and ints in a structured buffer? Because I feel like a visual. This might be something I have to look up, but typeless. Buffer. Come on. Typeless might work. No. Oh, hold on. Is that the right one? Oh, I need to start in debug to get the debug messages. I assume it's going to be, it's horrendous. Like, how can anyone work like this? All the windows all over the place. Create shader resource view typeless cannot be used. Right, I can't use typeless. I mean, I could make sure it's all... I tried to say I'll use uints and other values, but, you know, we could go RGBA 32 float. And that means probably be best off changing the format of the IDs to floats. So you have to have homogeneous data types, possibly, in a structured buffer. To be honest, I haven't ever mixed and matched, I don't think. I just thought if it's got a matrix in there, oh no, still something dodgy going on. Leave me alone. I don't want your stupid windows open. We've got all of this. First element, num elements. So now I think the problem lies with the bindless. Nope. Why was I saying that? It's not. I don't even want to go there. Raw. Okay. So we create a buffer that is size of entity instance data, right? And the format I'm passing in is unknown, but we do that for this as well. But the shader resource view needs to know. Obviously, format we could pass through, which I probably should do instead of using it hard coded. Then it's that. Then there's one number of elements. And what was the error message? Dimensions in the view are invalid due to at least one of the following conditions, assuming this format, RGBA 32 float, first element value equals 0. First element must be between 0 and the maximum offset in the buffer. 3, inclusively with the current first element. Num elements value 0 must be between, right, that's something, size in bytes, num elements, stride and num elements. So if I take where did it go? Here we go. Right, if I get rid of default, this is going to tell me what I need. That was the killer. Anonymous. Shader resource view desk 0. Buffer. I need this. Okay, that's fine and reasonable. Anonymous. D3D12 buffer SRV. So that one did catch me out. I did thought the default. I don't know. I really skirted around the defaults there, didn't I? Missing fields. Oh, first element. Oh, RTV. No, SRV. Okay, first element 0. I don't know if I passed that in. Non-elements. I should have this already. Non-elements. Structured byte stride. Already got it as well. Structured byte stride. Info. Stride. Flags. D3D buffer. SRV flags. What are they? And I don't know about this. We do info format. Does it use info format elsewhere? DXGI format is used. Is that used somewhere? DXGI underscore format. So that's used for an index buffer. Yeah, index buffer view. Okay, that's fine. That means we can use DXGI format here, which is quite nice. And I think we're saying, yeah, it's 32-bit float 4s. Weird because we don't get a matrix type. So obviously the first element, maybe we're doing array, like we're saying it's the first element, is the number of elements actually might not be quite what I think. Go to definition. Go to definition. What are these? Flag none or flag raw? I mean, for now, I'm just going to do flag none. Right. So if we say it's float 4s, we need to tell it how many arrays of float 4s it is. Shader resource view task 0. This is annoying me now. I'm getting tired. This. I want this. Cool. Right, so it's one of those. And then within that, we need one of these. And it's a union of, well, what's it called? Buffer. Okay. Is it like that? No. I don't need that. Okay, cool. Info num elements, that's going to be as a U32. And this is going to be a stride as U32. Okay, so I need to pass in, these might be different. So back to the code where I'm setting these guys from. Now I know. Format, RGB A32F. And number of elements actually is going to change. So I'm going to change world matrix. I was trying to be clever here. Well, not clever, but I made this whole generic math library, and I've basically just used Vec4F. So, well, I've used Vec3F, but I've always used the float. I haven't used any of the other like types, but I'm paying the crippling cost of the bloated code gen of generics in debug. So that's that. So now we know it's RGB832F. I reckon this is three 32Fs, RGBA32Fs, and this is one RGBA32Fs. So I think potentially there is 4 elements here, and the format is that. So let's have a go. I should have really gone in the debug build. I just want to go and have my dinner now, but I feel like I just want to push through the barrier and get something working. It's always satisfying to end on a working thing. That's what I've done on the last few. So, nope. GPU hang. Right, great. I just love it. You know? My bad neck. Bad neck. GPU hangs. Right. Oh. Hold on. Just create shader resource view. The format is in that. This is some ambiguity now of what the actual DXGI format means. So, which one am I in here? I'm in the right one. So I want to pass DXGI format in there. And when we create the buffer is, or the actual, so we create it for an index buffer view. But now it told me it couldn't be. Right. Create shader resource view. RGBA32 float is invalid. Okay. Which you know, I was happy with DXGI unknown, which meant DXGI format unknown, right? There might be somewhere else I'm using this format. Or maybe I can go back to using the integer version or the log. Oh my god. Right, no. Oh, right, it's not crashed. It's not doing anything, and that's fine. What are we on? Draw material, render meshes, vertex buffer instance. So firstly, that's incorrect. I wonder, can we put it back to DXG format unknown? It might have been just a bit of a mistake from me inputting the data. So then all of my subsequent rationale goes out the window. This does become unknown, which is the correct thing. And for the time being, oh no, and then there's not 4 elements, there's 1 element of data, of stride, right? Okay, don't really care. This is building. Right, it's reload success. It's not crashed. It's not rendering anything, but that's fine because my buffers are wrong. So I'm gonna go back to these guys. Oh, well, matrix pub IDs. I'm gonna go with vec for u, and for the first time, other than in the tests, I'm gonna use an actually integer vector. Get that money's worth. Okay. Not crashing. Brilliant. That's good to know. So now, let's see. All of this mumbo jumbo again, as usual. So we set up draw material. We've got rotate meshes. We can't see what they're doing. The render graph is mesh debug vertex buffer instanced. We don't want that. We created a new one, which is debug PMFX. Mesh material instanced, which should have compiled. I don't think I was getting any errors for it. So draw, pull that back. Mesh material instanced. Oh yeah, hold on. But that's the pipeline, not the render graph. So I need to create a render graph for that. Call it the same thing. Sometimes there is a bit of duplication. We want a grid as usual, just for assistance. Grid and mesh material instanced. So meshes, right? Main view no clear. Pipelines. Mesh material instanced. Render function. Render meshes. Material. See, I did call everything. Set up draw material. Render meshes material. So build this or jobs complete. Okay, and then, it should say it's missing functions, and then I can go and implement the functions. Okay, render meshes material. It's missing. I've been sticking all those into one big function. Render meshes material. Render meshes pipeline. Vertex buffer instance, C buffer instance. It's going to be similar to this one. Render meshes material. And then I have to think about registering the function and making sure it has the right components. So I think we do have an instance buffer, a mesh component, a pipeline. But we also have some other stuff. I need to do this. Right, it's still going to be missing. Let's see what I have. So, parent is an instance batch. I need to update that in an update function. And then we have the instance and the instance material. So really we want entities that have a buffer component, a material instance, and an entity ID. And do they have an instance buffer? What is it? What is it? Instance buffer. Okay, we draw from the instance buffer. Right, and that has a mesh component and a pipeline. The pipeline needs to be this one. Debug. Mesh material instanced. I think that maybe for now I'll call it mesh material. I might just call it mesh material and just always assume I'll be doing. So this is the thing that makes the draw call, and we pack in to here this information to be able to get that. So that thing, this stays actually the same, although that one, get rid of that. Come on. Almost some progress. So render meshes material, instance buffer mesh component pipeline, go. So that. Then instead of binding a vertex buffer for the instance buffer, we don't do that. Render mesh material, we don't set the pipeline per mesh. We just set the pipeline once. That improves the performance of draw calls there, so we're not doing that. We have an IB, a VB per mesh. We draw instances and we set the vertex. We do set a vertex buffer. Actually, we do set a vertex buffer. It's the same. I just need to hook this up. So we render meshes material. Render meshes vertex buffer instance. So it's the closest thing to that. It's basically the same, but with a different name. It doesn't have to even change. That's amazing. I don't need render meshes material because it is a don't need it. This one, I don't technically need to do that, but it doesn't actually matter. Setting it per pipeline, but I'll leave it as it is for now. I don't need that. And this is why I've got all this stuff. So what I do, I don't even need to do that. But you could use the same function again with a different view name, and the view name can kind of do different things for you. There's 2 of these have been registered, so that should be all right. Debug HL debug, and the function is actually vertex buffer instanced. So material instance uses an instance draw call. It's crashed. Why has that happened? It's going to crash again, is it? Oh no, it's working. Right. Anyway, render meshes material is missing, but that's because I've not saved that. I saved that as well. But... okay, can't find pipeline for mesh debug vertex buffer instanced. Why is it looking for that? So the draw call function. hold on. So that's the thing. And then we come in here, we get that. The pipeline. Ah, I know why. This got changes? Ah, okay, this has got changes. Mesh material instanced. I changed the pipeline name. And that's what's being loaded down here. The pipeline only needs to be set per pass or per view. So now we've got setup draw material, rotate meshes, we render grid, and we render meshes vertex buffer instanced. Here they are. They're green and they're tiny and they're at the origin because I'm not indexing. There's a load of them. That's like gone to choppy because of overdraw. So now, how exciting. I'm almost there. This has been quite the ordeal. I'm starving. My neck is killing me. I need a better chair. But it's close. I'm close now. So this becomes maybe a shader job. Shader job. Right. What have we got? This is our data, entity instance data. That has information in there. We packed that into it's only going to be a world matrix to begin with. I'll leave it there. I'll get the world matrix transform working and looked up, and then the next thing I'll move on to tomorrow or the next time will be getting the material info, and that'll be textures first, and then it'll be normal maps, normal transformation, then it'll be PBR materials. I'll get a bunch of them, and then it's one draw call, many materials. Then after that, the next thing would be to be able to make one single draw call with any meshes. So it's just a single draw call doing everything basically. That's the goal. Single draw call to do everything, if possible. Well, I know it's possible, so it will be possible. I don't have mesh shaders, by the way, so that's the thing. I'm on a 1060. Once I've got all this wrapped up, I'm going to move house, hopefully. I got a new job, but hopefully after that, I'll treat myself to a new GPU, and then I'll be doing ray tracing and like kind of advanced things, right? So struct, what have we got? We've got mesh material, I'm going to call it. No, it's not a mesh material. It's entity. An entity. I'm going to just call it entity. It's float 3x4. Which is its world matrix. I hope that doesn't cause collisions. I think structured buffers are scoped, whereas C buffers aren't scoped. And then we have a uint 4 of IDs, right? That's that. We've got a struct have these at the end in HLSL and C and C++. They don't in Rust. Come on, next thing. We need to add a structured buffer in here. Structured buffer is a thing. Entities. And these are also going to go on register T0. Here's where we run into trouble, where in this sample it's going to be fine, but let's see. Okay, it's compiled. Not got the old syntax highlighting on there. I think there was some enhanced like plugins or something for VS Code. Some guy at Unity was working on or something. I'll have a look into that. Right, so the one thing we have to do now is bind the heap. I need to bind the heap. But if I do this for the vertex buffer sample is going to crash or assert, and that's one of my tasks after this is to clean up how to bind things to slots. Maybe there could be an API to request if you do need to bind something, or it could have its own render function, but it's going to be device dot set rent shader heap. Come on. Oh no, get shader heap. Come on. I didn't say that. I said set. Is it bind? Oh, it's on this command buffer. Sorry. CMD buff on the view. View. CMD buff. Set render heap. Right. Oh, it's raining outside. So it's on slot 1, I believe, and this is that whole thing. I've mentioned about it a few times. Do you bind it? How do you know which ones to bind it to? How do you dynamically select that if you want to have shared code without having like a specific render path for every single combination of shaders? So this is going to be a thing I'm going to look into. The heap is off the device. Get shade heap. It only needs a ref, so it's fine. And the offset is going to be 0. Right. So this, let's see what that says. If it crashes, then this is one reason I've got that task in the list, because this has been an error prone. Oh, it's fine. Oh no. Fuck you, Direct3D. That might be one of the reasons why it was crashing before, but yeah, so this is gonna be, if I run the debugger, I hadn't saved that. Oh, dangling changes. 2.5 hours in. I've done this after work as well, so I've done a whole day of work, went for a run, and then did this. Come on, debug console. It's not giving me errors. That's not great. I'm not gonna lie. It didn't render anything. It's just doing this GPU, and then there's no. Hold on. It might be that I didn't have the debug console open. Oh, here we go. No root signature has been set. Right. And then core stack. VS Code is a rubbish debugger. You never know where anything is. You go main thread. It's on a render thread. Let's just get the thread. There it is. Okay, that's fine. It's like everything's there. It's just a little bit worse. So that's because I'm binding it before I'm binding the material. I need to clean this one up. But my intention was always that I can share these functions, because a lot of them do similar things. Bind something, draw stuff, bind things on slots. If you have some conventions, you can kind of make it a bit more consistent. Okay, well that worked. It didn't crash. I am binding I'm binding it now, the heap. So let's see if I can sample into it then. So this should be hopefully the easy part now. Which IDE am I in here? I'm in the big main one. Let me get rid of that and let me get back into here. Where Rust Analyzer working. Right, okay, we've got this. Debug HLSL. These are aliased on the same slot, so all of these types are all there. And here we go. Mesh material instance. So we're going to look up the world matrix. And we're going to have to know about the entity was world matrix and IDs. VS input instance. VS input entity. That's also IDs, but they're not scoped. I'm going to call that entity instance IDs. Oh no, they are scoped, aren't they? VS input entity. I believe that's uint4, and that would be text coord 4. That should be fine. Then let's double check that in the drawer. So well, we're not updating the vertex buffer yet, which I think that maybe I'll write the code, make sure it doesn't crash, then I'll finally write the function where we update the buffers. And that'll be a fun way to bring it all together. So the stride is size of a vec4, and the number of elements is a vec4u, importantly. So yeah, we've got a vec4u. We're kind of expecting it. And then we've got VS input entity. I'm going to call it entity, and then we can go WM is going to be equal to entity IDs 0. Right, is that right? But yeah, the 0th ID is going to be that. And then the world matrix is going to be, we're going to look that up. I'm going to just do this. World matrix, no, what's it? Oh no, that's called entity as well. We'll call that entity data. Entity data. Entity input. VS input entity. Entity input. Again, with the whole, everything's called the same thing. It's because there's quite a few levels of indirection, which obviously probably doesn't bode well for performance, actually. Entity input IDs, uint. Entity data IDs. So I'm looking at the material, but I could do that. You know, I could pack in the material ID into the vertex buffer. There's wasted bandwidth there as well. So that doesn't make sense. So I think I'd probably reshuffle that around. So entity data would just have world matrix. This ID, which is material ID, would actually go into VS input. I'm going to call that VS input entity IDs. PS input entity IDs. And this can be called entity input data ID, and then world matrix. World matrix. Right, come on. So then we have entity data, structured buffers, entities. I need this. Weird. That needs a type. Does that actually work? I thought it needed to be like this. That's not compiling. So we got entities ID. Okay. Unhandled exception. Here we go. Dot world matrix. Still build failed. Yep. No member named world matrix in structured buffer entity data. Are you sure? No member named world matrix in structured buffer entity data. But there is. Key error. You went for. No, annoying. This is now it's spiraling out of control. I need to go into PMFX shader. Key error. Get size type info. Get. Damn. I did all of these ones the other day. I did num32-bit values, uints, ints, halves, ints. So I don't know if you can use, I'm not sure about halves, but I'll just do these guys for now. These are asking for tuples. 16. It's going to be the same as that. 144. So what's that? There's one element and it's 4 bytes. And then on the 248, I think that might be rows and columns, is it? 248, the 3, they're always the same. Always the same as the other ones. Okay. 1, 2, 3, and 4. Right, now I have to go to config file, change this. It's approaching 3 hours. Right, it's against the clock now. I've got to do it in 3 hours now. I've given myself the challenge. Go away. Go away. Where the hell did I close the other one? It's just basically the ramblings of a madman. Right, I need to switch to the developer version of the shader compiler. Then I need to do that because I always do it. Then I need to run pmfx. Okay, so no member named world matrix in the structured buffer entity data. Are you kidding? Maybe it's 0. Is it 0? Because it's structured buffer. Because there's, you know, it's basically a one-dimensional array, which makes me think I should be doing it the other way, not per entity, but librs. Then I can use instance ID. Don't even need to push anything into a vertex buffer. It's given me plenty of ammo for thinking about and different stuff. Come on, where is it? This is why I'm like usually just like I will get tired and frustrated, but I can sort of power through. Versus provision says 3D mesh push constants entities. Come on. Will matrix 0. No, that's still having a problem. So that's not what I was thinking about. Let's go with this. Right, that's compiled. This was still running. That's kind of handy. I just don't understand. Ooh, let me check. I'm gonna have to check the generated, not assembly, the generated source now. Again, it's in the other workspace. It's just infuriating. Target. Oh, test needs to be fixed up. I'll do that before I push shaders. And there's temp debug. Right, what is it? PS mesh, VS mesh material instance. Right, what you want about there is no. What's a structured buffer? Hold on, entities. We're not using these for starters, so they shouldn't be there. Oh no, that's because I commented it out. Didn't I? Oh my god, this is making me extremely annoyed now. Extremely annoyed. Entities. So let's put this back in. I wasn't using it. World matrix 0 didn't work. World matrix whatever didn't work. Right, now it's included it. Structured buffer, entity data. It has a world matrix inside. Literally, it's taken me to here. Look, I should have just clicked that. Uh, I mean, this is how you use a structured buffer. I'm just looking at the first sort of Google I've had to do. This is an MSDN docs on another screen. Um, and yeah, you can have mixed data and you can access it. Struct entity data. Um, I don't know what it means. I wonder if it doesn't like world matrix. Let's see if it can let me access IDs. Uh, right, instance. Build failed. No, no member named. Side. I must be doing something weird. I wonder if can I have a non-array version? No, it's crashed. Oh, I've got some problems. Create a pipeline mesh material. Video just see the so if I can put this on T1. Oh, hold on. Did that compile? It did. So I can't have a bindless array of them. So that's interesting. That's interesting. That could be its own buffer, and it can be bind on its own slot. That's not a problem. That seemed to have compiled, I think. No problems with shaders. Now it's just going to complain. So I can't have a bindless array. Gonna have to look into that. Well, what's that now? Oh, it's not even 3 hours. I'm knackered now. Right, so it did let me have. Let's see if I can do bindless. Uh, This is something that I'm gonna have to fiddle around with. So unfortunately, didn't quite make it today. It's annoying because this, I can index into all of these. Okay. No member named this. Did see something like this, so should refer entity equals can it work? E E no. That's absolutely get binding type. Hmm. More shade compile issues. Damn, damn, damn. What was the type? Here is none. I think it might be something to do with this. It thinks that is a binding. Get binding type. It's this. I'm just gonna skip that. If not, continue. Okay, register type. Don't care about these in here. Come on. No. Doesn't like it anyway. User undeclared right. ID. To ID. It's there. Hold on. Yeah, no member inside anyway. Hold on. To be honest, I think this is going to be better with an array, a single indexed array anyway, but world matrix. Oh no. I'm gonna have to look into that. Right, I'm gonna call it a day now. So, where was it? Well, it's not even building now. Basically, close to having a bit of a material system, looking at structured buffers and versus C buffers and that kind of thing, and passing things through vertex buffer instances versus other methods. It's coming together, but it still needs a bit more work. So I'm going to leave it there. Bye.